Check out this absolutely wild pattern. 37 times 3 equals 111. 37 times 6 equals 222. 37 times 9 equals 333. This looks like pure magic, right? But here's the crazy part. This isn't a coincidence. There's a hidden mathematical structure that makes this pattern inevitable. This first equation is our golden ticket. Everything else flows from this one simple fact. Watch how. Let's tackle 37 times 6. Now here's the key insight. If we want to use our base fact that 37 times 3 equals 111, we need to get a 3 into this equation somehow. And notice that 6 can be written as 2 times 3. So let's rewrite 6 as 2 times 3. Now here's a fundamental property of multiplication that you've been using your whole life, probably without even thinking about it. When you multiply three numbers together, it doesn't matter which two you multiply first. 2 times 3 times 4 gives the same answer whether you do 2 times 3 first or 3 times 4 first. This is called the associative property, and it means we can regroup our multiplication however we want. So we can rearrange this and group the 37 and the 3 together first. We rearrange to get 37 times 3, all in parentheses, times 2. And look at that. This expression in parentheses is exactly our golden ticket. We can replace it with 111. And there we have it, 222. So we've just proven that if 37 times 3 equals 111, then 37 times 6 must equal 222. No magic, pure logic. Now let's tackle 37 times 9 using the exact same strategy. 9 can be written as 3 times 3, so we rewrite 9 as 3 times 3. Again, we rearrange to group 37 and 3 together. Replace with 111. And we get 333. The pattern isn't a coincidence. It's a logical necessity that follows from our golden ticket. Okay, but wait, we've explained the pattern using the fact that 37 times 3 equals 111, but that just pushes the mystery back one level. Why does 37 have this special relationship with 111 in the first place? What makes 37 so special? The answer involves a really elegant connection to a different number entirely. Consider the number 999, 3 nines in a row. This number has some really interesting properties when we break it down into its factors. Quick side note, numbers like 1, 11, 111, and 1111 are called repunit numbers. That's short for repeated units. They're literally just the digit 1, repeated over and over. These numbers have fascinated mathematicians for centuries because of their unique factorization properties. And 999 is 9 times 111, which makes it a particularly nice repunit product to work with. So first, 999 is obviously 9 times 111. But less obviously, it's also 27 times 37. You can verify this with a calculator if you want to pause and check, but trust me on this for now. Now here's the key. Since both of these expressions equal 999, they must equal each other. So we get this beautiful relationship. 9 times 111 equals 27 times 37. Now to get 111 by itself, we can simplify this. Notice that 27 is 9 times 3. Let's rewrite 27 as 9 times 3. Look at that. We now have a common factor of 9 on both sides of the equation. And if we divide both sides by 9, we get 111 equals 3 times 37. There it is. This is the fundamental truth that makes the entire pattern work. And just to drive this home, the pattern keeps going. 37 times 12 gives us 444. 37 times 15 gives us 555. Every multiple of 3 works. Let's see the pattern in full generality. When n equals 1, we get 37 times 3 equals 111. When n equals 2, we get 37 times 6 equals 222. When n equals 3, we get 37 times 9 equals 333. So in general, 37 times 3 times n equals 111 times n. That's the pattern. And it all comes down to the fact that 111 equals 3 times 37. This simple factorization of the repunit 111 is the hidden structure that makes what looked like magic into an inevitable mathematical truth. Pretty wild, right? If you enjoyed uncovering this hidden pattern, give this video a like and subscribe for more mathematical deep dives. See you in the next one.